Hello, everyone. It's a time of the keynote speech today. My name is Akio Kasuga. I will chair this keynote session. Today's keynote speaker is Ms. Magali Anderson. She is now a Chief Sustainability and Innovation Officer of Holcim. Magali graduated as I will introduce herself a little bit. Magali introduced as a mechanical engineer from INSA, Lyon, France. She started her career as a field engineer on offshore oil rigs in Nigeria. She spent 27 years in the oil and gas industry, mainly with Schlumberger, holding operational line management positions like CEO, Angola, and region head Europe. During her career, she also held several functional roles, including Vice President Marketing and Sales, Vice President Shared Services Organization for the Europe and Africa region, and Global Head of Maintenance. She joined Holcim as Group Head of Health and Safety in October 2016. She was appointed as a member of the Group Executive Committee and Chief Sustainability Officer in October 2019. In March 2021, the group announced the expansion of her role of Chief Sustainability and Innovation Officer, putting sustainability at the core of its innovation pipeline. Okay, so today's her title is Why Concrete and Cement are Key for a Net Zero World.
Thank you very much. Thank you very much for this introduction. And good morning, everybody. I'm very happy to be here with you today. As Mr. Akio Kasuga just said, I've just seen my career is a mix of business roles and technical roles. And that made me, when I got named Chief Sustainability Officer at the Executive Committee level, that really gave me all the tools and all the network I needed to make a step change in the way we are doing sustainability in the cement industry. So that's what I will be talking about today. And I will start by sharing my screen. So here we are. So I think it's important, you know, concrete and cement have a reputation of being big emitters of CO2, so we get questioned a lot on it. And I'm going to try to show to you today why it's actually key to have them for a net zero world and why we are an industry are part of the solution. So what we want to do, and that's, we have changed our identity and name less than a month ago. And our vision is to be the global leader in innovative and sustainable building solutions. And I hope it's clear when you see that sustainability and innovation are fully at the heart of everything we do, and not something that we are put, you know, we don't just give this title to someone and make it as a communication tool. So what we want to do when we say we are putting our expertise to work is we want to offer green building solutions, because at the end, cement and concrete are there to build a building, if I can say that way. So it's not so much how much cubic meter you have, how much CO2 you have per cubic meter of concrete, that's important. It's really how much CO2 you have in the final construction. So how do you better use those material to build better? Circular economy is very important, and I will come back to it. And of course, digitalization. So, sorry, I'm going to go back for a second in my screen sharing. Yeah, no, sorry, I just was not sure of something. Sorry about that, come back to it. So let me go straight to the meat of the presentation and pass the general messages, which I think you got by now. I think it's important to understand about Holcim who we are. And it's important to understand we're in 17 countries. Why I'm saying that is because when we announce a net zero pledge, we're not announcing a net zero pledge in Europe where there is some legal legislation help with the CO2 price, the CO2 allocation, etc. We also are going to do it in all our countries in the world, which is where big implementation in India, big implementation in Middle East Africa and Latin America. So also in countries where it's not necessarily obvious. And again, we have to do it in our 2,300 sites with our 72,000 employees. I will go back to the rest. I just wanted to maybe make a small note on the global R&D. We have the first, we are the only in our industry to have not only a global R&D, but a big R&D center. It happens to be in Lyon where I studied. That's actually a coincidence, but I was always happy to go back to Lyon. And we have 300 scientists and 1,000 patents. Half of our resources and almost half of our patents are actually linked to sustainability. But more than that, we work a lot with startups. We have accelerator where we invite startups to join us into thinking of how to decarbonize our industry. And for example, one of the startups that we worked with 2-3 years ago is a startup called Carbon Cure, which since have become quite famous when Bill Gates started to get interested in what that startup was doing. So a few facts about concrete and why do I say that it has to be part of the solution. It's the second most used material after water. And the urbanization trend that we are seeing, and it's of course we will always question what will be the impact of COVID and other climate change, is that there will be about 2 to 3 billion people who are going to move to urban areas in the next 30 years. And 60% of that infrastructure does not exist today, which means that we have to build the equivalent of New York every single month for the next 30 years. I am from Paris, so it's equivalent to also build Paris every week. But so what we're talking about is today, so that's for the next 30 years, but today 1.6 billion people need proper houses. And I'm not even talking about the 1 billion people who need access to electricity. So there is a huge infrastructure need, which is needed today, but also in the next 30 years, which will not happen without concrete. So now, when we talk about emission, of course, we fully understand that when we look at how we do cement, so in really a couple of words, if I want to explain to you how we do the cement, and you guys are all very technical people, so I'm sure you will understand that very quickly in case you don't actually know today, is that we have to heat up the kiln, the oven, if you prefer, to almost 1,500 degrees, 1,450 to be exact, and that represents about 40% of our emissions. These emissions, I will talk about it later, we are lowering them down by replacing fossil fuels by other type of fuels that are more sustainable. But then we calcinate limestones, and during this process, the limestones emit CO2. So that's one part that actually, whatever we do when we heat up limestones, it emits CO2. So it's not something we're going to be able to change, and that represents 60% of the process. Now, when we say that we are at the forefront of decarbonization of the industry, we look at the operations, we look at the products, and we look at the built environment overall. Because today it's nice to have a vision of net zero, and again, I haven't talked about it yet, but I will very soon. But what is even more important than the vision of net zero is what we do immediately. And what we do immediately is we now have our EcoPact, which is our green concrete, deployed in about 24, 25 countries. That's a concrete that is at least 30% less CO2 than the normal country reference. And we do it by country because there's huge variation country by country of how much CO2 you have per cubic meter of concrete. Same definition for EcoPlanet, except that's a green cement. And EcoPlanet we started deploying much more recently. But for EcoPact, we can go all the way to 70% reduction, technically. And then we offer for the last mile, the last 30% compensation in case people want to build a completely net neutral, carbon neutral building or something. Now, to be clear about compensation, and because it's always a big topic, none of the number I'm going to give you in the next minutes includes compensation. So when we talk about reduction of CO2, when we talk about net zero, when we talk about all of this, it's without compensation. So my duty, the duty of Holcim, is to lower the CO2 of the cement and the concrete. It's not to go and plant trees somewhere to pretend that we are lowering our CO2. So then I will talk about the climate net zero pledge, which we announced almost a year ago now. That was 21st of September, exactly, of last year. And the idea here is for us was to become a net zero company. And we were the first one to announce that with our 2030 target validated by SBTI, Science-Based Target Initiative. So I don't know if you all know SBTI, it's an NGO, which is now certainly the most reliable, the most renowned NGO to validate pathways. So I can't just go out and say, I'm going to get to zero and by 2030, I will be there, but without being on that actual, on the pathway to zero by saying that. So SBTI comes here and that's this target for us. Now, it was an interesting work we did with them because when we started, when we contacted them and when we started, it became very obvious that they had never done that work before. So they didn't know what was the pathway. So we worked with them to define the 2030, and we are now partnering with them to define the rest of the roadmap all the way to zero, which is something, again, that no one has done before us. So, and everything that we are doing in Holcim, at least under my watch, has to be absolutely scientific and rigorous. There is nothing, I will never announce a target or something that is not rigorous. So we will soon, at least in the next 6 months, we will publish our first climate transition report. And that's a report that goes into details of all the way to zero, including scenarios of the different, you know, in climate, you have the different scenario. You have the 2 degree, 1.5, well below 2 degrees, and of course, net zero. Now, our pathway to net zero, and this is scope 1. So for people who don't understand scope 1, 2, 3, scope 1 is our own emission, our own process emission. And in a lot of companies, you have scope 1, our own emissions, scope 3 is the energy, and scope 2, sorry, is the energy, and scope 3 is the rest of the value chain. In many companies, and you might have heard a lot of discussion on the oil and gas industry, scope 3 is how people use our product, etc., is usually way higher than scope 1. In our case, and I will share that a bit later, our scope 1 is by far the biggest. So that's why when we work with SBTI, we had to, the validation of the target was on scope 1 and 2 only, without scope 3. Now, the way the cement industry, via their association, is defining the way you talk about carbon is by kilogram of CO2 per ton of cementitious. And we do that so we all benchmark ourselves. I know we could go on absolute value, but absolute value is a bit meaningless because it doesn't show your true performance. If you produce more cement, you will produce more CO2. But at the end, if you are not producing that cement, someone else would. And if this someone else does it as a higher number of CO2 per ton of cement, then the planet wouldn't be the winning of that game. So today, we are quite below the industry or the sector average. We have an intermediate target of, we are at 555. We have an intermediate target of 550, and our 2030 target is 475, which is today the most ambitious at equality. Some people have now joined us on that target of the entire industry. And like I said, after 2030, we are working with SBTi to define the rest of the roadmap. Now, the way we are going to do it is to start with what we have started many years ago, because we already have reduced, I think, I didn't show the beginning of the slide, but we have already reduced by 28% our CO2 since 1990. So the cement industry was certainly one of the first ones to start working on them. And we do it, first of all, by operational efficiency. If your plant is more efficient, by definition, it will use less CO2. So we've been doing that for many years now. Earlier, I was talking about alternative fuel. So when our CO2, when we heat up the kiln to 1,450 degrees, we use a lot of fossil fuels, which we can replace by alternative fuels. Those alternative fuels are made of biomass, are made of waste, and it can be municipal waste, etc. So to put things in perspective, municipal, I lost the name, things to heat up that you use to treat your waste is below 1,000 degrees. So we are 50% higher in incinerator. Sorry, I had a blank. So city incinerators are about 900 and 950 degrees. We are way higher, which means that we have much less residues, and whatever is left goes straight in our cement process. So there is no waste left once we co-process our alternative fuels. And today we are averagely at 20% around the world, but we already have 2 plants that are operating with 100%. So technically we know we can do it. It's a matter of investment, because it's actually not costly as you remove your dependency to fossil fuel. But what is costly is you have to make a lot of investments for filters and all kinds of things. When you burn tires, usually your neighbors are not very happy if you don't do something good about it. The second one is, so when you heat up the kiln to 1,500 degrees, you come up with something that is called clinker. You don't make cement, you make clinker. And that clinker, once it's grinded, it makes cement. Now, the clinker itself, if you replace the clinker by something else to make cement, then the clinker is the one that needs CO2, that requires so much CO2 to make. The rest doesn't. So we use byproduct from the other industries, for example, slag from the steel industry, fly ash from the coal industry, but also some other minerals, such as limestone itself or calcium clay, to reduce our clinker factor. Our clinker factor today is at 70%. And we have cement today with a clinker factor of 20%, all the way even 5%, depending on applications, etc., etc. But of course, the more we lower that clinker factor, and it's a big part of our innovation, because it's not, obviously, it's not that easy to do. The more we lower it, the more we lower our CO2. And then what will be left, because we will never get to a 0% clinker factor, we can get to 100% alternative fuel. What will be left, we will require carbon capture. So the target I showed you earlier of 475 does not include carbon capture. So the carbon capture, I will talk about it. So here's actually the same slide, but showing more on the timeline. And renewable energy, I didn't talk too much about it, but that's for our scope 2, scope 2 being the energy that you produce. So the heat up of the kiln, the energy needed to heating up the kiln is scope 1, but the rest of the equipment that needs electricity to run, but also the lights in our offices, etc., will be part of our scope 2. And we have a big program to replace with renewable energy with the target of 65% reduction by the end of 2030. So our 3 scopes here, that's a good transition for the scopes, are scope 1, scope 2, and scope 3. And scope 1 is really the limestone. 47% is when the limestone reduces, emits the CO2. Scope 2 is a fuel. So as you can see, our scope 1 is about 75% of the total footprint. Our scope 2 is 5%, our scope 3 is 20%. So for the first time in the industry, we actually looked at our scope 3 and we gave ourselves a 2030 target on it as well. But majority of people, we never looked at it before, to tell you the truth. I mean, we were measuring it, but not really having action. A big chunk of it is transportation. We do 2 billion kilometers with our product every year, and that represents 25% of the scope 3. The other part is the management of the fuels that are needed for the kiln. And we never really looked at it, but when we were working on the pledge, we realized that even if it's only 20%, it's still 30 million tons. So it looks small in comparison to the other scopes, but in terms of absolute value, it's very high and we need to address it. So by 2030, we will accelerate the utilization of our products. So again, like I said, it's because we want to act now. So EcoPact, I mentioned it earlier. Susteno is a fantastic product. I absolutely love it. It's in Switzerland. It's a cement that when it's, which include what we call construction demolition waste. So think about it. You have, you have cement. That cement is used to make concrete. That concrete is used to build something, make a building of some kind. There will be a moment where you will be at the end of life of that infrastructure and you will have to demolish it. And when you demolish it, you take what we call the construction demolition waste. So you sort the concrete from the rest, you grind it back and you put it back straight in the cement. And this is just fantastic, right? This is just, it's a complete circularity, and we could almost consider doing it right where it is. So you are demolishing something to rebuild something else, and you could directly reuse. So now we only do it in Switzerland, and we use 20% of CDW in Susteno. And the reason being that the norms doesn't allow us to go further. So we are working with the Swiss authorities to push it to 50%. Of course, we have to prove that it's scientifically possible and that the cement will have the same strength than the 20%, obviously. But I won't finger point Switzerland, because that's actually the only country which accepts that we put a CDW in our cement. So one of the issues we are encountering today to go faster in our deployment is the fact that the norms are not quick enough to adapt to innovation. And that's really one thing you certainly will encounter in your future careers in the industry anyway. And that's a bit frustrating, because we have products we are ready to deploy that can really have a true impact on climate change, but the norms don't allow us. We are recycling today almost 50 million tons of waste. We are going to recycle 100 million tons. So 50 million tons of waste, to put things on perspective, is about the same size than a company called Veolia, which is a waste treatment company, and the biggest one, certainly in the world in terms of quantity of waste. And so that's a huge number. And some people like to say in our company that we are a waste treatment company that does cement as a byproduct. But it's very important, because a lot of the waste that we reuse, such as I was talking about slag, etc., would end up in landfilling if we were not there doing it. I talked a bit about calcined clay and novel cements, and that's because we realized that slag and fly ash are coming from industry that are going certainly that will be going down in the near future. So we will be clearly needing to replace that, to continue lowering our clinker factor. And I will go straight to the last point, which is we are very keen to prove that we can go to net zero before the end of this decade. So having a cement production, a cement plant fully at zero. Again, no compensation. I specified it earlier. So it's a true technical challenge, which is super exciting, in fact. And the way we're going to do it is via our carbon capture project. So we know carbon capture today has never been applied at full scale in the cement industry, but it has been applied in a few plants in other industry. Put things in perspective today, carbon capture in other industry capture overall 40 million tons of CO2. Our scope 1 alone is 110, 120 million tons. So that shows you that we're still very far. And that's why we have a total of 20 projects to test not only how we capture, and a typical cement plant would emit about 1 million tons. So we need to be able to capture 1 million tons at one place. And that CO2, we need to be able to do something with it. If we are next to a saline deposit or next to an old oil and gas depleted well or depleted reservoir, sorry, we can store it. If not, we have to use it. And utilizations, it's quite complex. We can transform it in minerals. We can transform it even in plastics, in synthetic fuels, like the Germany project. But again, it's a question of quantities of investment, because it costs, all those cost a lot of money. And if we have to be careful with that, because we can't transmit the full cost to our product. If not, we wouldn't be able to sell it anymore, which obviously is not what we want to do. So to do that, we have to advocate. I will just talk about one. There is today, you all know, in Europe, a CO2 price with allocations. And this allocation will go down because it's to push the industry to truly lower that CO2, which is a good thing. But it's a good thing if importers can't import without any CO2 pricing. So can't import a super dirty cement, while we would have a clean cement that will be more expensive because of what we are doing. So there is a question of border mechanisms, which you certainly hear, but that's why it is to protect the European industry. If not, the European industry will die very quickly if that was not happening. So the other one about energy for 2 seconds is because to do carbon capture, most of the technology requires a lot of energy, as to do hydrogen. I'm sure you guys know that. And so the cost of energy will be, and the availability of energy will be a huge topic in the coming years. So I talked about EcoPact, EcoPlanet. For the sake of time, I will go a little bit fast here. I just wanted to mention for 2 seconds the fact that we bought a company called Firestone beginning of this year, which is doing roofing. And we are going to move more and more to look at the full system. So for example, for the roofing, we can do not only, we can do green roofing, and as, don't know if you know that, but a lot of the energy losses in buildings is from the roof. So it's a very important component of decarbonizing the full construction industry. But also we can work together using some of our insulation. We have a foam that is actually a great insulator of top, and we can work with the roofing company to continue. I mean, today the losses of energy, depending on the countries, continue to be a major problem. In terms of usage of CO2, I thought I would mention a project called Carb. It's a French project, but we are doing other projects ourselves. That's a French governmental project where there's about 20 partners. But the idea is to use our flue gas, which is a gas coming out of the chimney without capturing, without nothing, which is great. So we can do it today. We don't have to wait for it. And we pass it through our aggregates or through our construction demolition waste. And the construction demolition waste absorbs the CO2. So not only it allows to lower the CO2 coming out of our chimney, but it makes our about 25% CO2 reduction of our concrete. And it makes it way stronger. CO2 had that faculty on minerals that it makes it stronger. And we have pilots in France, in Canada, and now we are launching one in Austria as well. It's a type of avenue that are great, because something I did not mention as I talk more about cement than concrete is that over its life, concrete reabsorbs 20 to 25% of the CO2 that was emitted to make it. And by doing that with the construction demolition waste, which means the rubbles, you know, they have been grinded, so they're in much smaller pieces, we actually increase a lot the absorption of CO2. We accelerate that process. We have been, we are partnered with Solar Impulse, and we have now, I don't know if you know Solar Impulse Foundation. If you don't, I encourage you to go and look at what they are doing. It's fantastic. It's Bertrand Piccard. Bertrand Piccard is the explorer that went around the world in this solar plane. He created the Solar Impulse with the challenge to have 1,000 solutions. Now he has 1,200, 17 from Holcim. And the idea is to have solutions that are good for the climate, but also good for business, to prove that it works, because solutions that are not good, that are good for the planet, but not good for business, one of the issues you have with that is that it's hard to sustain with time. You know, we can always put money in a pot, that's everyone can do that. But with time, if you want to make it at scale, it's not going to work. And that's why you need to find the right mix. And my challenge is to decarbonize 180 million tons of cement that we produce. So that's why it's so important that everything we do holds on the business side. I will just talk about one, is the artificial reef here, bioactive concrete. So we have a bioactive concrete that has such a shape and such a porosities that fishes and reefs loves it. So when we consolidate the shores, and as you have seen with tragic recent events that have happened just the last few weeks, we will require more and more to protect the shores, to protect the built environment from the water. And concrete is obviously the right material to do that. Then we will be using by using our bioactive concrete, we make an environment that reefs loves, and we will help having more reef, more fishes, etc. Now, so I just wanted to say 2 seconds about life cycle. And the reason why life cycle is important is because when you look at the CO2, you shouldn't look at CO2 per cubic meter of concrete. You should look at CO2 per square meter of building or infrastructure, whatever the building is, but also during the full life cycle. Because at the end, what's important is, again, for the planet, if you make, let me give you an example. I think that will be way easier. If you were building a house tomorrow morning, I assume you would buy double or triple glaze windows. So my question would be to you, why do you do that? Single glazed windows needs half the CO2 that a double glazed window needs to be made. And, but it's obvious, and everyone understands that over time, the energy you gain in heating and cooling your house using a double glazed windows compensate largely the initial extra CO2 and extra cost, by the way, that you spend by having double glazed windows. And that's really how you should look at it. And that's how you should look at concrete in the same way. So I was talking about the circular economy again. So I'm going a bit fast, and it's on purpose because I think it's more interesting for you to have a discussion than to look at slides. Now, I just wanted to finish. I have a couple of small videos, and that's a 3D printing passerelle that is actually, I don't know if this one is a true picture. It's always hard to realize what is true pictures from market, but I think it is. But anyway, we now have it installed. If you are in Italy, it's installed for the Biennale of Venice. But what's incredible about it is the technology about it. And I won't say too much because I have a movie showing it. But the only thing I want to say is, if you think about it, the construction industry hasn't changed that much over the last 100, 200 years. We make cement and concrete more or less the same way. Okay, now we have technology to make it a bit lower CO2, etc. But at the end, we heat up some limestones and it becomes somehow some cement. And that's been going on for centuries. And so there's not been real revolution in the way we build. So 3D is really 3D printing of concrete. It's really an incredible avenue of evolution. So let me go to the first movie. I have 2 quick movies just to show what it is. So that's my first video. And oh, sorry, not what I wanted to do. I wanted to go to the next video. Here it is.
What we're trying to do here is we're trying to demonstrate that perhaps we have forgotten some essential knowledge in the past, and that is to design for very hard constraints. I think the constraint is that we have only one planet, so that we have to basically build significantly more responsibly.
This is the new language of concrete and how we will be building in the future. For me, most exciting is they have selected to make a bridge. With this technology, we can make a skyscraper, we can make residential housing. It's beautiful, and that's why I'm so proud that we are a partner in this project with such a beautiful object in 3D printing.
So you need to also have high design, high engineering, fabrication, intelligence and knowledge, but all the way to logistics on the construction side. All of that needs to be taken into account in order to really disrupt and to be different.
So what's beautiful about that bridge is the fact that it's high strength without reinforcement. And the way you print is all about the ink. And it's all about the ink because in the first video, when you see it printing, basically you have the first layer and the second layer comes a little bit like this and like this and like this. And it has to be liquid enough to come out of the ink head, but of the printer head, but it has to be strong enough that when you come and make the second layer, it will hold and it will not splash. So technically, it's actually a super challenge. The person you saw talking the most with a small goatee is a professor, Philip Bloch from the University of ETH in Switzerland, and the other person talking is our CEO. And I think it's my last slide, so I will stop sharing now, and so we can, I can see people again and maybe answer questions.
Okay, Magali, thank you very much. So we have a time to Q&A. Her presentation it is very interesting and timely for the situation after the many countries declared of 2050 carbon neutrality. So, what is the first question from the audience?
No?
we think about that. So the first three, I will have some questions. And I understand the situation in the cement industry because there's some newspaper in the UK claim that, that if the cement industry is one country, it's the third CO2 emitter. First one is China and the United States and the cement industry. But concrete is very, very essential material for human, cheap and very strong and easy to cast at the site and fabrication, everything. So we use this concrete long time, more than 2,000 years. But now we have to reduce CO2 emission, especially the cement industry. But I understand that you are trying to the carbon capture storage project. But it depends. I think I know that the CCS is expensive at this moment, but in the future it depends on the cost of the carbon dioxide. So when it's a very lovely question. When will you come to the price of the CCS and the price of CO2 change at this moment?
No, it's not. So there's several. Your question is actually quite complex. The first parameter is actually the cost of carbon capture. Today, by using the technology of oxy-fuel, the cost is relatively high. It's about $100 or maybe a bit more. But that cost, if we look at other technologies such as membrane, absorption, etc., which we are piloting today, we have 2 pilots with membrane in US. In North America, that cost, we think, can go down to 30. So there is a huge technology challenge to reduce the cost of capture, which we think, and we more than think, we are convinced. Today, we are capturing 1 ton per day, which is not enough, of course, because we need 1 million tons per year. But that technology, we are already capturing 1 ton per day. So it works. We need now to scale it up. And once it will be scalable, it's going to lower drastically the cost. But there's adsorption, there's membrane. There are several other technology of capturing than oxy-fuels that are much cheaper. Just that, until very recently, no one really paid attention to carbon capture. There was all the carbon capture projects that started in the 70s were from the oil and gas industry to do enhanced oil recovery. So it was not for capturing carbon, it was for issuing more oil. So that's why today there's so much attention to it that I think those technologies will scale up. They will find a way. I mean, we have a decade to make it work. I have absolutely no doubt on it. And then once you capture the CO2, the second cost is what you do with it. So if you store it, if you are right above, like we have one of the plants, we haven't announced it yet, but we have one project that is, when we come public, we are very close to a old well, which goes to a depleted reservoir. This would be the cheapest because then the infrastructure already exists, the reservoir exists because it was there. Basically, everything you needed to do to take the oil out, you just do the reverse. So you have the same infrastructure, the pipeline, instead of being used to take the oil, is now used to inject the CO2. So the cost can be quite reduced. When it comes to utilization, that's where there could be quite a lot of cost. But again, it all depends on the infrastructure that is developed. For example, our West Coast Test 100 project in Germany, it's a project that we need to do, we do oxy-fuel. So we need the oxygen and to do oxy-fuel. And then we have an electrolyzer to do hydrogen. The two combined, we make green methanol. So you could use the green methanol immediately for the shipping industry. And that green methanol, you can build a refinery to do green kerosene. And that kerosene will be used by the aviation. Now, there's a cost to that, but today, the German government, for example, is very keen to help us doing it. So there is a lot of funds. There's the EU Innovation Fund that we actually applied. We passed the first things. We will have the result by the end of the year, but we're part of the selected project, because I think there is a common understanding that if we need this type of infrastructure, we won't be able to do it alone. And it's everyone, I mean, we need concrete. If you want tomorrow to build more windmills, you need concrete to make the fit. And by the way, we do 3D printed windmills fit with 70% less concrete, so which makes 25% more electricity for the same thing, because we make it higher. So you need concrete. We need to lower the CO2, so we are going to lower it quite a lot the next 10 years. But after that, for carbon capture, some projects will be beneficial by themselves. And when I look at the projects we have, a few are already beneficial by or will be. I mean, we have feasibility study. Some projects we will need help from funds, but again, the funds are working right now.
Thank you. So I'm a bridge engineer with construction company. The cement industry is our scope 3 upstream side. So we are very, very looking forward to the zero emission cement coming out the field. So please accelerate your research. Okay.
You are right, because today our EcoPact, we sell it with a premium price, which helps financing everything we do in decarbonation. And so we could sell much more. We are ready to sell much more. We need to find the client. Today, you have people, either the private sector, we have their scope 3, and they need to reduce their scope 3. Either the governments wants to lower. So half of our cement goes to infrastructure development, which is public projects. And that's where it's up to them to say, we want green concrete for that. And we are ready for it.
Okay, thank you. So we have some questions. So Jean-Michel, you ask yourself, please.
Okay, thank you, Akio. Yes, my question was about the financing of all the infrastructure you will need to capture and store CO2. Do you think the countries are ready to finance it?
No, but it's really a case by case. So some will require financing, but you see, for example, today we have a capture project in Spain where we use our CO2 for farming, and they are ready to buy the CO2 for about 70 euros. So that actually pays for it. So some projects pay by themselves. The projects where we will do storage and you need to build a big infrastructure, or the West Coast 100 I was mentioning in Germany just earlier, will require financing. So it's really not a one size fits all. For sure, we will have to start with Europe and North America, because Europe, you have the CO2 price, so the ETS allocation, which helps obviously. Today, the CO2 is above 50 euros, as you know. So it's getting to a level which is completely financing what we are doing. And in the US, one of our projects got the funding financed by the DOE, the Department of Energy. But also they have a mechanism called 45Q, which reimburses today $50 or $60 per ton of CO2 in tax advantages. So those countries are putting that. What for Holcim roadmap to 2030, we don't need it. 2030 to 2040, if we do all of Europe and all of US or of North America, we will be happy. So it gets after 2040 that I think by then we will have found enough technology, and maybe countries will all have a CO2 price. You know, it gives us 20 years to attack, between brackets, the countries that are maybe a bit more complicated because they don't have the right incentives in place yet.
Thank you.
Okay, we have another questions from Anton. You mentioned about capturing CO2 in products. What if these products are recycled for another application? It will lead to release of CO2. Do you take this into account in the calculation, and how does this influence of CO2 reduction goals?
Yeah, so you're right. There are a lot of discussion on that, huge amount. and at EU level a lot, because the ETS today for utilization, if your CO2 goes to utilization, considers that you should not deduct it from your numbers, which is obviously a big problem. So we are discussing that a lot. And that's why storage, there is a bit of that problem, is storage is badly accepted by the population, onshore storage at least, because people think that the CO2 will come out straight away. I spent many years, as you saw in my presentation, in the oil and gas industry. I can tell you that we know how to store it permanently, but I fully understand why people would doubt that. And when it's utilization, if we can't deduct the CO2, of course, for us, it will be a major problem. So there are a lot of discussion. Now, there's two ways of utilization. If you think of the West Coast 100 project, I will continue talking about this one, which becomes kerosene. On a financial point of view, if the airline industry want to reduce their CO2, they don't have many options. I mean, I know we talk about the hydrogen planes, but I think it's going to take a while. I think the synthetic fuel will come earlier. So so then we'll need to buy it. So on a financial point of view, it actually can work because they will buy it, but then it won't reduce our CO2, which is not helping us in our roadmap. And if you think about it, cement should have emitted 1 CO2, airline should have emitted 1 CO2, that's 2 CO2, now we emit only 1. So you still have reduced overall by 2. But who takes the credit? Is it me or is it the airline industry? And that's where all those negotiations are ongoing, because of course, on the total count of CO2 for the planet, you can't count 2 reductions, or you can't count it twice either. So it has to, at the end, the calculation has to make sense. But you have other usage. And for example, when you use CO2 to recarbonate minerals, like the FastCAF project, or when we use CO2 to make synthetic plastics, then the CO2 is captured. I mean, once it's a mineral, it doesn't go away again. So in that case, there is no more emission of it. But of course, the storage is the best one. The only problem with the storage today is public acceptation. So I think there is a big work that is required to scientifically prove to the public that it's okay to have CO2 stored 5 kilometers below your feet. It's not going to come out.
Sorry. Before George, we have 2 questions from Amina. What do you think about the regionalized approach to the reduction of CO2 practices for the production of environment-friendly cement and concrete? Since, as you also said, the byproducts availability change, as well as the percentage of the renewable energy in the electricity mix of the countries, etc. So what do you think?
Yeah. So yeah, it's obviously, so the numbers I gave are global. And that's why I insisted earlier at the start of my presentation on how global we were. Of course, some countries are more or less, and you're right, it is a regionalized approach. It's not something that, it's not a one size fits all. If you think about it, some countries still have a lot of coal. Some countries still have a lot of steel industry. So slag and fly ash will still be available for many years. If we talk about those byproducts, and that the reason why we are working so hard on novel cements, because in some countries that will not be available anymore, and we will need to replace them by calcined clay and those novel cements earlier than others. But it's really country by country. We also have to clean the past. If you think of fly ash, yes, you have fresh fly ash, if I can call it that way, coming from the coal industry, but there's a huge amount of fly ash that has been landfilled over the years, which we can collect back. So we clean the past, we clean the landfilling, and we can repurpose that land. But of course, there's a bit of a cost associated to it because it's contaminated, obviously. If it has been landfilled for decades, it's not as good as the fresh ones. So it's really, you are right, it's completely regionalized. And that's why I was saying the green cement is 30% below the country, because we have some countries like India where the CO2 per ton of cementitious is very low because there's huge availability of slag and fly ash there. And countries like US where it's actually quite high because they do the lowering of the CO2 at concrete level, not at cement level. So it's completely regionalized. However, all our targets, all our measurements are at a good level. So there's no question of saying we are going to decarbonize one region and not the others. The other problem we have in certain regions is that is the collect of waste. When we use municipal waste or other waste as a fuel, if you're in a country where the collect of waste is not very well organized, then it becomes complicated. So we actually have actions at Holcim to collect waste ourselves, which is not getting a little bit far from who we are and what we do, but that's because we are trying to compensate for that. And now renewable electricity, etc. You are right. I mean, it depends on the country, but I think it also depends on how carbonated the electricity of the country is. So we try to prioritize countries with very high carbon intensive electricity. For example, I think by now you all understood I was French. France is a country with very low carbon electricity. So it might not necessarily be our priority compared to other countries where we will get much more in terms of CO2 saving by doing what we call PPA, which is power purchase agreement. So we have wind farms and solar farms in quite a few of our plants now. You're muted, we don't hear you.
Sorry, sorry. So we have another questions. So from Jakob, he asked, you are talking about the 3D printing. He asked, how is the ductility of such a printed structure, because there are no reinforcement? How do you keep the ductility?
Well, that's the full beauty of it. So today we are doing a person passerelle. So again, I mean, it has been fully calculated that we absolutely know. And as you saw, there's quite a few people on it. So it can take quite a few people. It's pretty strong. It would take too long, and I'm not sure I would be the right expert to actually explain how it is done, how the reinforcement is done. But yes, we are not capable as of today to do a bridge with cars on it. But that's definitely something we need to work on. This is a part of the innovation, because again, when you look at, you said when we look at how much CO2 the industry is using, the reinforcement, the steel bars in the reinforcement is a huge part of it for the concrete. So obviously finding a way to replace that by we have carbon fibers, we have all kinds of projects on that, finding a way to replace the reinforcement by something more sustainable or no reinforcement at all is a huge challenge that we need to work on, because that would reduce quite significantly the CO2. Okay, so we are running out of time, but before Georgie, there is 2 short questions.
Thank you very much. I have a similar question to the previous one. Actually, we can continue a little bit. So I enjoyed very much your presentation, all of your presentation, and a little question about the 3D printing. This was a nice example. And I often think that 3D printing can be more valuable in bridges than in buildings, especially in large structures, in compressed structures. So in this example, I guess that there was no additional reinforcement supporting the structure, but the very interesting is the joint, how they create the joint and the support and so on. This is very important. And you mentioned the fibers and the different possibilities. This is for the future. This is very important, actually. So incorporate some kind of reinforcement in 3D printed concrete is very important to solve for us.
So yeah, I would say, and we can, we do today. We are able to do it. I would say in 3D printing, there's many super interesting challenges. I mentioned the feet of the windmills, where we have much less CO2 and we go much higher. And that's pretty nice. So you can lower enormously the CO2. And then we mentioned something else, is we are doing 3D printed schools in Malawi. Malawi has a shortage of 36,000 schools. So here it's not so much a technical challenge itself, it's the speed of execution. And we can print a school in 18 hours. Of course, you still have to come and put the roof, etc., but the walls, which is 4 or 5 times less than traditional construction. So we have printed our first one. And we can bridge shortage of this type of infrastructure, of schools, etc., in some countries with 3D printing. And people are questioning, but why do you do 3D printing in Africa? You know, there's so much traditional. And it's true, except that the shortage of schools in Malawi has been going on for decades and had not been solved. So the speed, the lower CO2, the flexibility. I'll give you another quick example. You are renovating a road. And you know, in a road, you have those places where all the pipes connect. In French, we call it regard. I'm not sure how we say it in English. So that's a bit of things where all the road connects, etc. Traditionally, you would cut the road, open it up, and you would have to do all the farm work, and it would take forever. And then during that time, you know, if you do that in a very busy place, people will be pissed off because the road is now cut down for 3 weeks, 4 weeks. You can 3D printing it a few hours. So what you can do with 3D printing in terms of renovation is incredible, because you can put your design in the machine, if I can call it that way, and design something completely fit for purpose, which we all know in renovation is a problem. You need fit for purpose parts, which you don't know quite often in those old buildings before you have started the renovation. So you can gain so much speed, and renovation, as you know, is a big challenge of the future if we really want to reduce CO2. Expanding the life of the building or infrastructure in general is super important. So 3D printing, I have enormous hope into it myself. I think it has a bright future for decarbonizing the industry, helping innovation, etc.
Thank you. Thank you.
Okay. So 2 more questions, Magali. And from Omid, he said you talk about the CO2 reduction, but in a country like Emirates, new coal-fired power plants is being built now. So what should be the balance for this?
I mean, I can't really comment on other industries, but I think all of the industries are now being having the same challenge. The steel industry is doing a lot in terms of finding, you know, working with hydrogen and decarbonation, etc. But that's why carbon capture is not a cement problem. It's an industry problem, because many industry need it. And that's why, and if you look at, I mentioned Bill Gates before, and the reason why I mentioned him is because we know he's quite visionary in general. And if you look at, he invested in carbon capture technologies because he understands that if we could lower the cost of the carbon capture technology, and we need to all get together to do that, all the industries will need it one way or another. So.
Okay, so it's not easy. Why? Everybody knows. The final question from Omar. So you talk about the fact that the standards do not follow the increasing rate of the development of your products. What do you propose to standardization bodies to solve that?
Sorry, I'm not sure I fully understand the question. Standardizing our products, or?
Yeah, standardizing the bodies to solve that. What do you propose?
It's when you talk about Sustaino, you say that you are not able to increase.
I mean, it's really, it's an advocacy thing. You know, advocacy sometimes is considered as a bad word, but it's not always a bad word. So it's working with the authorities and with the legislator to explain why our product is good, and to actually show our product, show them that, you know, do all kind of tests and resistance tests of all kind, etc., which are required to prove that it's good, and then it's work in progress. We hope to get the norm evolving in Europe between end of 2022, early 2023. So we're just working with them. There's no magic stick here. It's working with them, it's advocating, it's, sure, yeah. There was a question I saw from Jean-Michel, and maybe if I have another 1 minute, where you ask about roadmap design. So you're right, today, and I said it a couple of times during my presentation, CO2 per square meter over total life cycle is what is important. I only started my job 1.5 years ago, so what I wanted to tackle first was the cement, because the cement is a big emitter. So we have to tackle the product, but the real progress will be looking at the full building. So I am part of the WBCHD, which is a World Building Council for Sustainable Development. I'm the co-chairing of the built environment work that we are doing, where we're trying to all get together as the different actors to find a way to attack the environment, the full built environment. So that's why as an individual company, it was important to tackle the cement. But the next step, my next priority is work I'm on now, but that will take longer because you need to get everyone to agree. You need the construction company to agree. Will be really to how do we reduce the entire built environment and how we all get together. But to give an example, today we don't even have a common measurement. So that's really doesn't help. So I didn't want to wait until I thought that would take too much time. So first we work on the cement and then we work on the design, et cetera, which is something that we are engaging. We've been engaging for a while now, but we'll be accelerating in the near future.
Okay, thank you, Magali. So we really enjoy your presentation today, and we still have many problems to solve. So it's a long way, but we should go to the goal. Okay, so I won't close the keynote session. So thank you very much, Magali.
Thank you.
See you.
See you. Bye-bye.
Merci.
Bye-bye.